You want to go millimeters to kilometers first, and then kilometers to miles, right? Now this first one, millimeters to kilometers, that's an easy conversion, isn't it? Because that's just moving your decimal point. So how would we do that millimeters to kilometers? We're going to take this decimal point and move it which direction, how many times? So yeah, we go back to our little table. There it is. So we're trying to go from millimeters, which is here, all the way to kilometers. So 1, 2, 3, 4, 5, 6 places to the left is where we're going to start here. So this right here becomes 1, 2, 3, 4, 5, 6 places. So 0.004378 kilometers equals this many miles. So now this is pretty much like the previous problem, isn't it? Yes? Okay. I'm going to let you finish this one up yourself. I'm just trying to illustrate here that you might have to do more than one conversion before you are done. Should we get an answer or no? Just to have it? Make sure you do it right. I'm getting 0.00272036. That's what we're getting. All right. Tell you a quick little story before we move on to the next one. Is everyone aware that we have like a rover on Mars? That we've had several rovers rolling around on Mars, digging holes and testing things on Mars? You don't know that? Okay, well, before we actually got to Mars, we started to, here's Mars. We first sent these probes into space, and what they did is the first one we ever sent, we wanted to go and just go into orbit around Mars and just kind of take pictures, look around, say, we should go try and land there later. We're just going to analyze what we're going to do. So one of the first probes we ever sent, we sent it out and we lost it. It didn't do what it was supposed to do. And we found out later that when it got there, it just crashed right into the surface. It didn't go in orbit at all. And we lost this, multi-million-dollar machine, right? So they went and they looked back and they said, okay, what happened? Where was the mistake? Well, it turned out that the groups of engineers working on the probe, the software, there were some engineers from Europe and there were some engineers from the United States. And guess what they didn't do? They didn't convert from metric to imperial and imperial to metric. They were working in two different systems of measurement. So everything was coded in properly, except that there were conflicts, and so when it got there, distances weren't being measured properly, and we lost it. So in a class like this, if you mess up a conversion, then you just get some points taken off, right, on the test, but they shouldn't be making those mistakes, right? Would you agree? Yeah. All right, so let's discuss area, because we haven't talked about area, and I think area can be a little bit confusing. So when you write this down, let's say 1 foot, we all understand that means you take this, you measure 12 inches, 1 foot, right? So it's a measurement of 1 foot, from here to here. It's a length. But if you write 1 foot with the little squared above the foot, you're no longer talking about the length of something. You're talking about what's called area. And area is two-dimensional. It's 1 foot this way. Then you draw a right angle. Oh, too big. Well, let's move it down. 1 foot this way. 1 foot this way. And you create this box. This right here is 1 square foot. It's 1 foot by 1 foot. And this is a measurement of area. And then if you write 1 foot with a cube, a 3 up there, that means you're talking about a volume. So you're talking about a box that's 1 foot wide, 1 foot tall, and what? Sorry, that's a little tilted, but 1 foot wide, 1 foot tall, and 1 foot deep, or 1 foot long. So it goes back 1 foot, down, over. That's a box, a cube, right? So this is a measurement of volume. And the only way you know the difference between the three is that little number that's right here, okay? So here's a question. If I have 1 foot, how many inches are in 1 foot? 12 inches. Agreed? Now if I have 1 cubic foot, how many, I'm sorry, I said cubic, I apologize. If I have 1 square foot of area, then how many square inches of area do I have? So it's not 12? No, it's not 12. Do y'all see that? Because, look, what would 1 square inch be? It'd be 1 inch by 1 inch, right? So imagine cutting this up into the 12 inches this way and the 12 inches this way. Then you're going to have how many of these little boxes along the bottom? 12 here, another 12, another 12, another 12. So you're going to have 12 this way, 12 that way. You're actually going to have 144 of those, aren't you? So this question I'm about to pose to you is this. How do we convert these areas and volumes? Because it's not as simple as this to this. So that's what we're about to do, all right? So let's just do this problem right here. What if you have 3.2 square meters? That's 3.2 meters this way, 3.2 meters that way, this box. I would like to know how many square inches that is. So this can be very different than what we just did. So do we have anything on our chart that allows us to go from meters to inches? Yes. Got to look at that chart. I don't have it here. Where is it? Meters to inches? Where at? Centimeters. We can go centimeters to inches, right? We can go centimeters to inches, right? Okay, so we have to get this converted over. How in the world are we going to do this? So,
centimeters to meters?
Do it. Say it again.
Would it be easier to go from centimeters to meters?
You mean from meters to centimeters? Is that what you mean? Yeah. To go from. So what do y'all think? Should we go meters to centimeters? Are we just going to move the decimal point over? So here, just watch what I'm going to do here. 3.2 meters over 1 times 1 meter over 1. Now that is different than anything we've done, isn't it? And it's because we have the meters squared. I want you to look at that as meters times meters. Now I just put a 1 there because it doesn't change anything, right? Do you all agree that this right here is that right there? Okay? So first thing I'm going to do is I'm going to convert this over to centimeters. So what is that in terms of centimeters? So go to your chart here. If I want to take 3.2 meters, which is right here, and go to centimeters, I've got to move the decimal place how many? 2 places to the right. So this right here becomes 320 centimeters over 1. Agreed? Now I have to convert this meters over to centimeters also. So 1 meter is how many centimeters? 100 centimeters. So the biggest mistake that you have students do in a problem like this is they just move this over 2 places and they change that to centimeters squared. And that's incorrect. You actually have to take each meter separately and do its own conversion on each one. Make sense? Okay, now that we have this, where's our switch from centimeters to inches? This is it right here, right? This is our conversion. So, Restim,
Yes.
how could I do this using the equivalence relationship that we have right here?
So we have to create another proportion.
Okay, we're going to create a proportion.
Yeah.
Which one do you want on the bottom?
I want the centimeter.
Centimeter on the bottom. So can I just take this and put centimeter right here?
Yes.
And then what's going to be on the top?
The inch.
Inches. And then go ahead and let's fill this in. So what goes in front of centimeters?
That means 2.5.
2.54, right? And inches?
1.
1. And this will allow the centimeters to cancel, right? But only one of them, right? Only this one and this one. What's still here?
Is one more.
Another centimeter. So you got to do this again.
Okay.
And it's actually a good thing because when we do it again, right? Do that same thing again, and these cancel out, then how many inches am I left with? Inches, inches, right? Inches squared. Make sense? All right. Let's get an answer for this. I'm going to do all the numbers on top, multiplied. And then I'm going to divide it by the 2 on the bottom. Someone want to tell me what they're getting? 4,960, right? Someone else get that? Close? No one did?
Oh, yeah.
You got that? Okay. I'm getting like 0.01 or something like that. Square inches. Questions? You look like you have a question. You sure? All right, so this is a little bit more involved, right? Because you've got to take the meters, get it to centimeters, so you have to split the meters up, convert each one to centimeters, then kill off each centimeter with your proportion. And that means you need 2 proportions. What do you think if this was a problem like 3.2 meters cubed into cubic inches? You would have to go 3.2 meters times meters again. You'd have to have 3 meters here. Convert each of the 3 meters over to centimeters. Then kill off each of the 3 centimeters with 3 of the inches conversions. So it's a little bit more. All right. You all look thrilled. Let's do one more. We'll cut out. Let's do a volume one. Something with volume. So these are our volume conversions. Okay, these are the things I would give to you. I don't see gallons on there. Do you see gallons? Oh, there it is. There's gallons. All right. So let's go and do this. I want us to do 2.5 times 10 to the 4 sorry, not millimeters, milliliters. I want that over to gallons. And this is all you're given over here. So I gave you a number in scientific notation. I told you that's how many milliliters we have. And I want to know how many gallons this is. Wait a minute. Jameson, didn't I call on Jameson already? Put you back in there. Marcus, Where's Marcus? Marcus? Do you see anything on this chart, Marcus, that would help you get from milliliters to gallons in some way?
In some way, but not directly.
Not directly, right? So what's the path that you see that looks the easiest to you? Have you looked through all of them yet?
Fluid ounce, milliliters, fluid ounce, and then from pint
So-
to fluid ounce.
And then from what?
Pint, fluid ounce,
Fluid ounce to pint. Where's that one? Oh, right here.
and then to quart,
And then to quart.
and then to gallon.
And then to gallon. So you could do it that way. Do y'all agree you could? So,
Oh,
Marcus,
wait, that was the
okay.
long way.
Yeah, that's the long way.
So it would be fluid ounce to, or milliliters to fluid ounce.
Okay.
Then to liter, then to gallon.
Okay. That would work.
Yeah.
Do you see anything faster?
Or milliliters to liter. And then liters
We could go milliliters to liters and then liters straight to gallons, right? So, yes, you could have done it those ways. On a test, I don't care the way you do it. I just, as long as you get there. I want to do the path of least resistance here. I would like to go from this to liters and then straight to gallons. So, and the thing also is I don't mind converting this to liters because it's metric to metric and that should just be decimal point, right? So I'm going to first rewrite this. 25000, let's see, 1, 2, 3, 4. So this is that number, milliliters, right? That's this converted to, not converted, just rewritten. Now, to go from milliliters to liters, we're going to move our decimal point how many places? 3? Okay, so I won't scroll up to the table. I'll just trust that you know that that's going to move 3 places. So we got 25 liters, right? Marcus, you're still looking up there. Are you okay?
Yeah.
Okay. Christian,
Yes, sir.
you're going to help out. We kind of converted our milliliters to liters. Here we are at 25 liters, and we are going to do what now?
So we're going to want to cancel out the liters.
Want to cancel out the liters.
So I'm going to
So I'll help you with that. Okay, now,
go 3.7854178.
where? Yes, but where do you want it here?
On the bottom.
On the bottom. Okay, so 3.784178 liters, and on the top is your 1 gallon, right? All right, and that's it. The liters will cancel, and so we'll be able to do this.
5 after the 8.
Did I mess up on this? Oh yeah, 5. I did. All right, so 25 divided by that number. We're going to do one more after this. I'm sorry, I lied to you. Okay, so this should come out. It's about 6.6 gallons. One last one, all right? I promise this is it. Let's do one that has to do with speed, the speed of something. In physics, a lot of things are measured in meters per second. So what if I had this object that was traveling 54.6 meters per second? I would like for us to convert that into mph, miles per hour. Because we're all familiar with miles per hour, right? That makes sense to us. So what is 54.6 meters per second into miles per hour? Well, the first thing we have to understand here is that when you say meters per second, this already is giving you a proportion. It is giving you 54.6 meters for every 1 second. And what we need to do is multiply this by proportions that are going to get rid of the meters, turn them into what? The meters need to be turned into miles, and the seconds need to be turned into hours. So we have 2 things to deal with here at the same time. So let's start with the meters. How can we get from meters to miles? So I'll look at our chart and see if it's there. Do we have a meters to miles? Go back up to distance. We have kilometers, right? We have kilometers to miles, right? Kilometers to miles. Okay, so let's rephrase the problem. I'm going to leave that up there. Can we change this to kilometers? 54.6 meters in every 1 second. Can you switch that over right there to kilometers? Okay, how? Move the decimal place how many places? 3 to which way? Left. So this is the same as 0.0546 kilometers per second. You with me? I'm not using a conversion factor here. I'm not multiplying by anything. I'm just saying this is the same as this, right? Now we come in with our conversion factors. I want the kilometer to cancel, right? So Alyssa, where's Alyssa? Alyssa, how am I going to get my kilometers to cancel here? Kilometer on the bottom, mile on top. Okay, so this is 1 mile. I'm going to put mile this time. And then this is the 1.609344. Everyone good with that? Kilometers, sorry, I forgot to put kilometers here. Kilometers are going to cancel. Alyssa, do you want to keep going? Good, thank you. You want to? No? Yeah, so we're going to multiply across, but before that, what I want you to do is, do you agree we've moved from meters to miles? We've achieved that goal,
Yes.
right? How are we going to get, though, from seconds to hours? You have to have some sort of relationship between seconds and hours, don't you? So not everybody knows how many seconds are in an hour, but I think you know how many seconds are in a minute, right? There's 60 seconds in 1 minute, right? So it was Alyssa, right? Alyssa, I'd like for you to multiply by a conversion factor here that would switch your seconds to minutes. Okay, so which way do I write it here? Everyone pay attention. This is a critical step here. I'm trying to get from seconds to hours. You know that there's 60 seconds in a minute, so what goes where? Would you put the seconds on the bottom? Would you? Yeah. Why? So on the top then?
Yeah. Oh, yeah. So
You said bottom, right?
Oh, yeah.
Okay, so here, instead of putting, see the seconds are on the bottom here, right? So we actually want our seconds on the top this time, right? That way they'll cancel. So there are 60 seconds in 1 minute. Y'all follow that? It's the first time today that the unit we wanted is in the opposite place. And that's because the one we're trying to get out of, seconds, is on the bottom, so we want it on the top over here. Now I'm going to run out of room, so I'm just going to rewrite this so I can continue this. 6 kilometers over 1 second. We multiply that times 1 mile over 1.609344 kilometers. And then we multiply that times 60 seconds over 1 minute. And then Luke, where's Luke?
Right here.
Luke, is it Lucas?
It's Luke.
On the roster, it's not Lucas?
On the roster.
Okay, I just want to make sure because I was trying to put your grade in. I was like looking for Luke. Okay, all right. So I want to make sure I didn't have 2 students here, 2 different ones. All right, so there we go. Luke, we're going to try now. We've got, yeah, so this time we're trying to come in and get our minutes to go to hours, right? So we're going to put the minutes on top again so that it'll cancel with the minutes on the bottom. There are 60 minutes in 1 hour. And so our minutes are gone, our seconds are gone, our kilometers are gone, and everything should be in the unit that we want. This is dimensional analysis. This is what it is all about. You're trying to go from one thing to another. And the way you set up these proportions is all dependent on where you're trying to go. If things are on the top, you've got to put the unit on the bottom so it cancels. If it's on the bottom, you got to put it on the top. All right, so I'm going to do, or you're going to do this number times 1, that doesn't matter, times 60, get that answer, and then divide that by this. Who has that for me? 196.56 mph. I'll just put mph, miles per hour. Oh, before you divide. Sorry. Okay, yeah. Divide that by the other one. Sorry. What, 1,000?
That's what I, oh, wait, I'm going to multiply.
Yeah, I think you.
It's 122.13672.
That's good. mph. Let's see if anyone else gets this, just so we can have a confirmation. You got that?
Yeah.
All right. So this, again, is one of those problems where if I were to say, hey, this object was moving at 54.6 meters per second, you may not have a good idea of how fast that is. You might be like, man, that's like speed of light fast, or you might be like, oh, no, that's not very fast. But if I give you this, I think everyone understands how fast that is, right? Mm-hmm. That's about what you drive down the highway. All right, so what do y'all think of that conversion? It is what it is.
It's easy. Well,
So do your homework, practice. We are stopping here at dimensional analysis, but I believe you can try everything in the homework, and you may have questions next class. Let's see, metric conversions, yeah. There's some word problems in there. See how it goes. Have a good weekend.
So we still do the homework scheduled for today?
Yeah, try it. I think you'll see some problems that are very similar to what we did in class, and then others are going to be more involved. Okay. We'll do some more of these word problems next time.
so percent proportion.
Percent proportion, try everything out. In metric conversions,
Do those mistakes.
yeah, hold on. Let me just look at this. Oh, if you want your exams, I can give them to you. If you want, you can hang out and get them. Yeah, so percents and proportions, try that. Scientific notation, dimensional analysis, you can get started on it.
Okay.
Okay, I'll just call your names and then I'll put them down here so that people can get to them. See, Victor, David, your grade, I believe, is online. I don't have it here, but just subtract that number, the points off from 100. Miranda, Dyson, Nivany, Brianna. There's 2. That one? Okay. They just happen to be next to one another. Boy, that's weird. That's happened more than once with you, hasn't it? Okay, Aaron, Tanisha, Gloria, Paris, Marcus, Alyssa, Christian, Anissa, Gabriella, Timothy, Jared, Luke, Rastim, Elizabeth, and Laura. Okay, so Timothy and David, no? All right. Yes. Oh, wait, hold on. Let me turn off my camera. Yeah.